Hello all. Welcome to my video lecture on Essentials of VLSI Design. I am Dr. Jyothirmai Joshi, Assistant Professor EIE Department, VNR VJIET. Today I want to discuss about the introduction to the stick diagrams and the layouts. So basically, what are stick diagrams? Stick diagrams are generally the representations of IC process design, IC VLSI design process. So VLSI design aims to translate circuit concepts onto silicon. The stick diagrams are the means of capturing topography and layer information using simple diagrams. Stick diagrams convey the layer information through color codes. Those are called as monochrome encoding also. And they act as an interface between symbolic circuit and the actual layout. And what these stick diagrams show? They show all the components and the vias that are the connectors. It shows relative placement of the components, and we can say that they go one step closer to the layout and they help planning the layout and the proper routing of the components. So we can say that the stick diagram is a cartoon of the layout. And what they do not show? They cannot show the exact placement of the components, transistor sizes. What is the exact size of the transistor? Generally, when we try to see the transistor sizes, they are represented by lambda, the feature size. But these stick diagrams will not represent this feature size based on the lambda based rules. The layout will be applied with these lambda based rules. And they cannot show the wire lengths, what is the exact wire length, wire widths, tub boundaries, and any other low level details like parasitics. So these are the stick diagram notations, how they are represented using different monochroming and monochrome color coding and general colors. Metal 1 is represented by blue or the dotted lines as shown in the screen. Poly is by red. N diffusion is green and P diffusion is yellow. And contacts or the tubs will be generally represented in the dot. Stick diagram has certain rules which has to be followed. So first rule which represents here is given in the screen. When two or more sticks of the same type cross or touch each other, that represents an electrical contact. Here the metal is given. This is the metal. And this is N diffusion as we have seen the colors. Then rule 2. When two or more sticks of different type cross or touch each other, there is no electrical contact. Here the representation we have, this is the metal and this is the poly. When these two are crossing or cutting each other as shown in this figure or this figure, this is the first figure and this is the second figure. As shown in these two figures, if they are cutting or crossing each other, this represents there is no electrical contact. If we have to put an electrical contact, that has to be exclusively shown here. This is what is the contact that we are showing. This black one represents there is an electrical contact. This is rule 2. Then rule 3. When poly crosses diffusion, it represents transistor. See, this is an green, N diffusion is green and poly. When N diffusion and poly are crossing each other, not touching, crossing each other, it is an NMOS transistor. Similarly, when actually this is yellow. This is yellow, which is representation of P diffusion, and this is poly. When P diffusion and poly are crossing each other, this is called PMOS transistor. Then next the rule 4, it represents that when I am designing a CMOS transistor. A CMOS transistor consists of a PMOS on the pull-up side and NMOS on the pull-down side. And in order to separate these two, that we are representing that the pull-up side is PMOS and pull-down side is NMOS. This is called demarcation line. This is the demarcation line that we represent that both are separated. Hence, in the CMOS, a demarcation line is drawn to avoid touching of P diffusion and N diffusion. And all the PMOS will be lying on the pull-up side, that is one side, upper side, and all the NMOS will be on the pull-down side. This is what is the fourth rule. And another representation is when I want to represent my depletion mode transistor. Generally, this pull-up side, what will we do is we represent the transistor as usual with the color. Say suppose this is diffusion and this is poly. We put a box here. This is the representation of depletion mode transistor. So this you need to remember. These are the rules when we want to draw the stick diagrams. Just we have to know now how should we draw the stick diagrams. How can we draw the stick diagrams is following these rules. The first and foremost step that we need to follow is we need to draw the VDD and the ground lines. This is the initial step. Then the demarcation line representing or separating pull-up and pull-down side, PMOS and NMOS sides. Then this represents our N diffusion. This represents our P diffusion. These two are the diffusions. Then next we are putting the vias here. These are called as vias or connectors, which is showing an electrical contact. As discussed in the stick diagram rules, we told that when two materials are touching or crossing each other, there won't be electrical contact. If I want to make an electrical contact purposefully, I have to put a via. So this is what is a representation. Then next, this is what is the poly. When we discussed already, when P diffusion is crossed with the poly, it is called, this will be the NMOS transistor. And when P diffusion is crossing with the poly, it is called PMOS transistor. And this part is called pull-up side and this part is called pull-down side. So this is what we draw first. Then we need to make the connections for this. How do we make the connections for this is, if you see here, this is a metal, VDD, and this is a metal which is VSS. This represents VDD. This metal represents VSS. And here if you try to understand, we need to connect. We need to connect these two. These two, NMOS and PMOS. How do we do this? You see here, we try to understand this with respect to the schematic diagram. Generally, when we see the schematic diagram, how will be the schematic diagram is, see, there will be a pull-up transistor and there will be a pull-down transistor, and this is PMOS and this is NMOS device. We short these two and we give the input here. And this is the VDD line and this is the VSS line, and here we take V out. If you understand this, this is a schematic diagram for the inverter. This is the inverter schematic diagram. Right, the same thing we are trying to represent in the stick diagram. What are we doing here is, see, this is what is our VDD line which we have shown here. This is the VDD line. This VDD line we are representing here with this VDD, and then VSS line, this VSS ground. Then this PMOS transistor, how is it formed? When I cross P diffusion with poly. When I cross P diffusion with poly, what do I get? I get the PMOS transistor. And when I cross N diffusion with poly, I'll get NMOS transistor. So both the transistors are drawn, and initially a demarcation line was given separating both, and now I need to connect these two, right? This line. Here this is the line which I am drawing that is connected through a metal. So this blue one is a metal, and here I'll be giving my V out. And here this is the input line which I have to connect, as both, if you observe, both are polys. The material that is poly, you can connect these two through a poly line. We need not use a metal because the material is the same. So I have connected that using the poly and given it as VN. And this is how we draw a stick diagram for a inverter, basic inverter circuit. Just I'll show you that example here. So this is a general transistor, right? And before we go into the stick diagram, I already told you there is a layout for it. It is a cartoon of a layout. How the layouts will be drawn is simple example. Just I'm showing this for this NMOS transistor. See, this will be representation of your NMOS transistor where this is N diffusion. Right? That is N diffusion, which is represented with a block of green. Right? And then it is crossing with a poly. This is how I give a representation of layout. So this is a poly, and whenever a N diffusion is crossing with the poly, this represents your NMOS transistor. So for the stick diagram, we use the monochrome encoding or the lines, a thicker sticks. And for the layouts, we use the blocks to draw the layouts. Right? So this is how we represent the stick diagrams and the layouts. This is a simple schematic. Just now I described you the inverter, right? So this is a schematic of an inverter circuit. This is an inverter circuit. I discussed already. This is our PMOS transistor. This is our NMOS transistor. And here when I give an input V in, I get V out, which is an inverter. How does this work? We'll just try to understand that. See, suppose that I have given, this is a digital logic. So if I give 0, what happens? We know that PMOS will be on and NMOS will be off. When this is done, what happens? The signal is applied to both PMOS and NMOS. PMOS is on, therefore this V out will be pulled up to VDD. Therefore, what do I get? For an input 0 applied, the output that I get is 1. Then, next, now if I apply 1 here, what happens? Here the PMOS is off and the NMOS is on. Therefore, what happens? The NMOS will be on and the signal will be pulled down to 0. Therefore, when I applied Vin is equal to 1, I am getting the output as 0. That is, V out will be pulled down to ground. So with this logic, you can say this is an inverter circuit and the schematic diagram of an inverter circuit. And how the layout is represented is this is the layout. Here we'll try to understand the schematic in the next slide. Right. If you try to see here, see. Here this is our blue VDD, this is our ground, and then what are we doing? We are taking a P diffusion on the pull-up side, N diffusion on the pull-down side, and you are connecting that, crossing that poly here, and you are connecting the poly to give the input X, and again contacting both with a metal, NMOS and PMOS with a metal, and that metal you are giving your output. Therefore, if I apply X, the output that I get will be X bar. So this is the layout. In between comes our stick diagram. Right, before we go into the layout, the stick diagram comes into picture. So this is what is our stick diagram. What are we doing here? See, this is our schematic. This is our layout. And see, these are our sticks. This is VDD. This is VSS, that is ground. Then what are we doing? We are taking two metals. Then this green representing N diffusion, P representing P diffusion, and both are connected through our polysilicon. The poly is crossing the N diffusion forming NMOS, and poly is crossing P diffusion forming the PMOS when we attach each other. And if you observe, see, there is a via here, there is a via here, there is a via here, there is a connector here, there should be a connector here, there should be a connector. So this is what is our stick diagram for our inverter, NMOS inverter. Thank you. This is what we understood how the stick diagram can be drawn.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.